division or radicals. For this part of it, and the first part of it, you're really not dividing radicals. Really more of the first part is you're really going to be simplifying. So we'll start with square root of 5 over square root of 45. So even though it's division of radicals, the very first part of it, you're really not dividing anything. I mean, you are, but you're not really dividing the radicals for this part. Then basically, if they give it to you where you have two different radicals, then if you have 5 over 45, you can divide them both by 5, right? So what they tell you is, all right, so what you can do then is put those two numbers together, like it was just one regular fraction, and simplify that fraction down. So it would be the square root of 1 over 9. And once you've simplified that down as much as you can, well, now you can break it back apart. You've got square root of 1 over square root of 9. Square root of 1 is 1, square root of 9 is 3. So then you get 1/3 for your answer. So it's division, but really in the first part of it, it's really more of just simplifying a fraction. Okay, for second example, let's do square root of 30 over square root of 15. And for both of those, and again, you can either leave it as two separate fractions. They tell you to go ahead and think about it as one fraction, that it's the square root of 30 over 15. Well, if you have 30 over 15, square root of 2. And once you've got the square root of 2, there's nothing you can do to simplify the square root of 2, so square root of 2 would just be your answer. Okay, and then the last one we'll look at before we change things up just a little bit. We'll look at square root of 49y squared over the square root of 81. Okay, now for this one, you actually have perfect square roots. So you've got the square root of 49, make it 7. Square root of y squared, well, that's just y. Square root of 81 is 9. So if they do give you some with some perfect square roots, this is almost going back to section 3, I think it is, where you had to do some of this, where you were simplifying some radicals. This is almost where they kind of give you some problems, just taking you back a couple of sections ago and just have you breaking those down. So if you have perfect square roots, go ahead and do that. If you don't have perfect square roots, put it together and then see what you can simplify and then break it down from there. And one more of those with some variables mixed in. Okay, so let's go with square root of 75 m to the 4th over the square root of 3 to the m. Okay, so putting that all together in one big fraction. You have 75 over 3, m to the 4th over m. And for that m that's on the bottom, again, just think about that, that's to the first power. 20 25 divided by 3, sorry, 75 divided by 3 would be 25. And when you subtract your powers here, that would be under the third. So square root of 25 would be 5. If you have 3 m's, you can circle 2, take one of the m's out, and leave it with one of the m's on the inside. Okay, so there's where they're, again, still kind of mixing together what they call new with division, but it's almost the same thing we were doing earlier with just some of the simplifying radicals. And have you work through some of those. Also, just kind of more of a reminder, since we're doing those, just one more quick one here. If you had the square root of x6 over the square root of y to the 12. Now again, you could go through and write 12 y's and circle them in pairs, but because it's square root, that you can basically take y and do 12 divided by 2. And for the x, you can do 6 divided by 2. So 6 divided by 2 makes that x to the third. And for the y, 12 divided by 2 is 6. There's no leftovers, no remainders, so for those would come out perfectly without any square root stuff. Okay, so we'll spend the first few examples just going back and reviewing, just making sure everything's, basically remembering all the basics, just a couple of things that you can kind of go with these. And here's where they actually have you work through simplifying a little bit more than just breaking down the numbers and just doing a lot of fraction simplification. Here's one where they're going to give you some quotients involved. They're going to ask you to simplify, it's a quotient with a difference or a sum. So big thing is it's simplified, but the detail they're going to add in is this time, all right, we've got quotients mixed in with sums and differences. So for this, we're going to have 15 minus the square root of 50. And that's over 30. Okay, so the first thing you have to do is you've got this square root of 50 and you've got to break it down. And if you break it down, it's 25 times 2. And with the 25, you've got a perfect square root. So that would be 15 minus 5 square root of 2 over 30. Okay, so as far as the radical goes, that's as much as you can do with the radical part of it to break it down. The next thing you can kind of look at it is you can do it a couple of different ways. The way they show it in the homework, and actually it looks like they'll take either answer, is once you've got it here, where you've got 15 minus 5 square root of 2 over 30, break it up in two separate parts. Do it as 15 over 30, and then minus 5 square root of 2 over 30. And then simplify the first fraction, simplify the second fraction, and just do as much as you can. So if you've got 15 over 30, that would be a half. 5 over 30, that would be 1 over 6. And then the square root of 2 would kind of hang out with it there. Now, because it's 1 times the square root of 2, you don't have to put the 1, just leave the 1 off of it. Okay, now here's one of those times where sometimes they'll let you have this answer. The answer they're showing with the online homework going through Alex is they actually have you go back and get these with common denominators, which to me is almost kind of a step in the wrong direction, because to me that's as simplified as you can get there. The answer, though, that they show for one like this is that they're going to want you to put these two back together. So really you'd almost have to put this back so it's 3 over 6. Then square root of 2 over 6. And then you can just do 3 minus square root of 2, so it's the whole thing over 6. But to me, that's almost a step backwards, because you had a simplified fraction here, and then now you've made it bigger. So that's one of those that hopefully they'll let you put this answer. But it seems like that this is kind of where they're going with the homework through Alex. But I kind of like this one because you've broken it down as much as you can possibly do to get there. The alternative, and they give you, here's one where they kind of give you two different examples. The alternative answer they kind of give to you here is they say, all right, if it's 15, if you just look at the numbers, if it's 15, 5, and 30, where you've got the square root of 2 that's here, well, we're just going to leave the square root of 2 off. What's the one thing you can divide? What's the common factor with 5, 15, and 30? What number can you divide into all those? Divide them all by 5, right? So they tell you, which is probably where they want you to go with this one, if you can divide them all by 5, well, go back and divide them all by 5. So you can make that 15 divided by 5, that's where they would get the 3. 5 divided by 5 would be the 1 with the square root of 2, and 30 divided by 5 would be 6. So if they don't let you have this answer, which to me they should, because to me that's more simplified than this answer is, but it just kind of depends on how they're wanting you to put the answer there. So they show you both options. To kind of get you there. But, you know, I kind of like this one because you can simplify it up and break it apart as two separate fractions, and there's actually some times when you go into pre-cal that you actually want to do it that way, where you've got it as two separate answers. All right, so I'll show you a couple more of those. Okay, now, actually, here's the one thing they're trying to get you to see for this part, is using that with the simplifying part of it. They're actually going to have you go ahead, and the next thing is to kind of use what we had there. They're going to ask you to rationalize. And with the first example that we had there for this part of it, it's kind of where they show you the simplifying part of rationalizing the denominator. So they kind of show you the very end of it. Now they're actually going to go back and pick up the first couple parts with the rationalizing here. And when I talk about rationalizing the denominator, here's what it means. When I tell you to rationalize the denominator, that means that you cannot have a radical in the denominator. So to rationalize the denominator, to fix that, if it's just a single term denominator, that to rationalize it, you just multiply by the exact same square root you have in the denominator, but you multiply that to both the numerator and the denominator. So to rationalize it, we're going to multiply the numerator and the denominator by the radical in the denominator. And one other thing we'll put with that one is, that's as long as if the radical, or if the denominator, is one term. If it's a two-term denominator, a little bit different, same thing, but we've got to do one little thing different to it. But the first part that they're going to give to you when we're going through these is they're just going to give you a one-term denominator, and it's easier to simplify that one than it is if you have a two-term denominator. Okay, so let's give you a problem here. So let's say that you have 9 over the square root of 5. And they ask you to rationalize. So what we'll do is we'll take that 9 square root of 5, and we're going to multiply the numerator and the denominator by square root of 5. Okay, top part would be 9 square root of 5. Okay, bottom part. Now, you can look at it two ways. The way they kind of looked at it last time, in one of the side examples we did, if you have square root of 5 times square root of 5, they tell you, well, if you have 2 of those, it's square root of 5 squared. And the square and the square root would cancel so that you get just 5 in the bottom. You can also do it the same way, that if you do 5 times 5, well, that's 25, right? Well, it's square root of 25. Still 5. So either way you go, you get 5 in the denominator. It doesn't matter which way you look at it. So you get 9 square root of 5 over 5. So we can either say it's the square root of 25, or again, you could say that it's the square root of 5 squared. Either way you go, you still get 5 for the answer there. Okay, so let's give you a couple more of those. Let's go with 14 over the square root of 7. So we've got 14 over square root of 7. We're going to take the original fraction you have and multiply by square root of 7 over square root of 7. Okay, and the bottom part is, again, if you do 7 times 7, that's going to make it 49. When you square 49, that's going to be 7. So we've got that. The top part is just 14 square root of 7. And now that you got 14 over 7 on the outside, that part you can simplify and make it 2 over 1 with the square root of 7. But if it's over 1, you don't really need the 1. You just make it 2 square root of 7. If you're starting to notice a little bit of a shortcut, maybe you aren't, that if they give you whatever the number is here, The shortcut is that you kind of start seeing the pattern. You're going to move the square root from the bottom to the top, and on the bottom, you just take the square root off and just give me a number. So if you can get used to that shortcut, you don't, it's still thinking through this process, but that's the way it's going to work every time. If you have to rationalize it, move the square root from the bottom to the top, and then just take the square root off the bottom. And then you can simplify whatever you have left over there. Okay, do the same thing on this one, just change it up a little bit different. Actually, let's make it 2 square roots here. Let's do square root of 14 over square root of 21. Okay, so you could kind of go through the same process on this one, that you could multiply both sides by square root, or multiply the top and bottom by square root of 21. But if you notice it's 14 and 21, you can divide them both by 7, right? So for this one, go ahead and divide them both by 7. Just simplify that regular fraction like it's 14 over 21, so you can make it square root of 2 over square root of 3. That way you're still going to simplify it and rationalize and go through it. It's just now the numbers are going to be a lot smaller when you start to break this thing down. Okay, so we're square root of 2 over square root of 3. Now again, you can technically multiply the top and bottom by square root of 3, but if we know the shortcut, we're going to wind up moving the square root from the bottom to the top, and then just take the square root off the bottom. So the only thing we have with it there again is that if you wanted to, wait, I'm sorry. Both of those square roots are underneath there, aren't they? I was looking at it like, wait a minute. Square root of 2 times square root of 3 would make that square root of 6. Sorry. Over 3. And wrote it down. I thought something doesn't look right, and it didn't quite click with me first. So there's one, if you have a square root, you actually have to multiply the top and part it together. And you would have gotten the same answer here if you had done square root of 21 times the top and bottom. But if you had used that, you would have had square root of 14 times 21 on the inside. Just a lot bigger number to try to break down. So if you see that you can simplify it, go ahead and simplify that thing first. It's going to save you a lot of work and effort when you go through that one. Okay, so let's go with 8 over the square root of 5x. A little different look to it. So you're going to multiply the top and bottom by square root of 5x. And the bottom part again, that basically because you have the same thing squared, that you're just going to get the 5x back out of it. And then the top, well, there's nothing you can do to simplify that part. Okay, but again, if you kind of get used to the shortcut of it, if they ask you to rationalize, we're doing the same thing. We're moving the square root from the bottom to the top, and on the bottom, you're just going to take the square root off. And then simplify and see what you can do there. All right. one more of those and we'll do one thing a little different here. Okay, let's go to square root of 3x over the square root of 98. Okay, 3x, we're good. Now, square root of 98, really big number, right? So before we start having to multiply by square root of 98 and moving numbers around, if you think about 98, that's 2 times 49. So with the square root of 49, we can just take that out and make that a 7. So you have square root of 3x, that's over 7, square root of 2. So even though you've got some big numbers with the 98, that really if you take it and break it down as much as you can, that's really the problem we're going to start with. So it's 3x over 7 square root of 2. And now, again, all you need is just the radical part. So you're going to take and multiply by just the radical. The 7's a whole number that we've taken it out. That part's okay. You only have to worry about the radical part to rationalize it. So on the top part, it's 3x times 2 on the inside. So that would be 6x. On the bottom, it's 7. And you're going to take the square root off the 2 and just make it a regular 2. So top part square root of 6x, bottom part would be 14. So they're still kind of tying back to the last section before that. If you can simplify it a little bit, go ahead and simplify it a little bit. It'll just make the work a little bit easier as you're working through it. Okay, and then the last thing they're going to look at in section 6. Still rationalizing. And they word a little bit different, but basically this part, you're going to rationalize a 2-term denominator. Okay, now here's what we're going to do. You're still going to have a square root in the bottom part. You maybe only have 1, you might have 2. Just depends on the terms they give to you. I think in most cases it's going to be where you still just have 1 square root. But then you're going to also have a whole number to go with that square root. So this is where you're going to multiply the numerator. And the denominator. By the conjugate of the denominator. And again, for the conjugate, that just means that you just have to change the plus or minus sign in the middle. Okay, so if it's a 2-term denominator, you're still going to use the square root, but the only thing you're going to do different is you're just going to change it. But if you're given square root of 3 plus 2, you're going to change it to square root of 3 minus 2 and multiply the top and bottom by that number. Okay, so here's an example. Again, still the same direction, they're still just going to ask you to rationalize. they're going to ask you to rationalize 2 over the square root of 5 minus 3. So we're going to take the original problem we had, and all we're going to do is now we're going to multiply. Instead of just using the same denominator, we're going to change it to where it's square root of 5 plus 3. And we'll do that on top and bottom. Okay, now here's where we kind of tie that back into the multiplication part we had last time. That technically when you do that, you would wrap this one in parentheses, same thing here, and because you've got the 2 terms here, they don't give you parentheses, but when you multiply, you have to think about those terms being in parentheses. Okay, for the top one, there's really not much you can do. It's just distributive property. So it's 2 times square root of 5, which would be 2 square root of 5. And then it's 2 times 3 to make it 6. Okay, bottom part, you are going to have to do the full method. But the thing about the conjugates is, when you multiply those together, the O and the I term in the middle always knock each other out. So all you really have to do is do the square root of 5 times the square root of 5, which would be square root of 25. The middle 2 terms knock each other out, and then you're going to be left with negative 3 times positive 3, which would be negative 9. So when you do that part, you go to square root of 25, which is just 5, and then you have 5 minus 9. So that part would be 4. So top part, again, we did distributive property to get to here. The bottom part, when we do the full method, we get this. So that's just going to be 4 on the bottom.
Would that be a negative 4?
Yes, it would be. We'll make it negative 4. All right, now, again, here's where I want you to kind of go back and simplify on these. And for me, this is where I would break it up into 2 parts, but they probably are going to tell you to leave it as 1. So when you get here, you're going to look at just the whole numbers. You have 2, you have 6, and then you have the 4. So we can divide into both 2, 6, and 4. Divide everything by 2, right? So you're going to go back and divide everything by 2. Because they're all multiples of 2. So then your final answer for that one, you would have square root of 5 plus 3 over negative 2. Now, test question wise, if you had that broken up, like if you had broken this up into 2 parts, where you had 2 square root of 5 over negative 4 plus 6 over negative 4, so that you had square root of 5 over negative 2 plus 3 over negative 2, I would take that one, separate it out. They're kind of looking for this answer where it's one big fraction, but, to me, either one of those 2 answers would be okay. That's one where I'll go back and check it just to make sure you get some partial credit there. Okay, so for next example, just throwing one more out here. One thing we'll do different is just change the top term. Or instead of it just being one single term, now you've got 2 terms in the top part. Okay, same thing. You're going to start with the problem that you have. and then multiply by the conjugate. So we're going to change that to a plus. And 4 plus 2 square root of 3. And the biggest difference on this one is that because the numerator had the 2 terms, you are going to have to do the full method there. And then we are going to have to do the full method on the bottom. So for the top part, we'll do the full method in blue. The bottom part, we'll do it in green. Just try to separate it out there. Okay, for the top part, you've got 3 times 4 for 12. You have 3 times 2 square root of 3, so that would be a 6 square root of 3. You have negative square root of 3 times 4, so that's a negative 4 square root of 3. And a negative square root of 3 times 2 square root of 3, that would be a negative 2 square root of 9. Okay, the bottom part. And again, the good part about the bottom part is the O and the I will cancel each other out. So all you have to do is do the first 2 terms. It's 4 times 4 for 16. And then minus, here we got to be a little bit careful. It's 2 square root of 3 times 2 square root of 3. So it's 2 times 2 for 4. Sometimes it's easy to leave that as just 2 because you're in the mood of you're focusing on the square roots. That sometimes it's easy to forget that it is still 2 times 2 for the 4. When you do 3 times 3, that would make it square root of 9. Okay, so then start simplifying everything as much as you can. For this part, you have 12. You've got 6 square root of 3 minus 4 square root of 3, so that would be 2 square root of 3. And then because square root of 9 is 3, you've got 2 times 3 to make that a minus 6. On the bottom part, you've got 16 minus 4. When you square root 9, that would be 3. So on the top part, you have 12 minus 6 for 6. Plus 2 square root of 3. The bottom part, you have 16 minus 12, which would be 4. And for me, that's where you would separate it in 2 parts. But again, they're kind of looking at it as one big fraction. So all the terms here, you can divide them all by 2. So then you've got 6 divided by 2 for 3. 2 divided by 2 for just 1, or just square root of 3. And then 4 divided by 2 would make that 2.
Where did you get that minus 6 at?